Okay, this is part 8, and it should be the last part of our formative exam review. We're starting off with number 32. It's asking us what is the percent by mass of oxygen in iron 3 oxide. And it gives us the formula mass, which is 160, which is nice. So we don't have to do that calculation. There's iron 3 oxide. It equals 160 AMU. We're pulling that right out of the question. It did the work for us. We want to look at how many atoms of oxygen we've got in this molecule total. There are 3. They weigh about 16 AMUs each, which gives us a total of 48 AMU. We want to take our part, which is 48 AMU, divided by our whole, which is 160 AMU. That's going to give us a number, and we're going to take that number and multiply it by 100, and that's going to give us our percent oxygen. Number 33. All right, number 33 is asking us which pair of formulas represents both the empirical formula and the molecular formula of a compound. So we want to look at the ratios of these formulas. When we look at A, we are given CH2O. That is a 1 to 2 to 1 ratio. So our molecular formula has to be in that same ratio. C4H6O4, what we're given with A, is not a 1 to 2 to 1 ratio. These H's are off. If it were H8, it would be correct, but it's not. Let's look at B. B gives us an empirical formula of CHO, which is a 1 to 1 to 1 ratio. The molecular formula we're given with that is C6H12O6. That is not a 1 to 1 ratio. The hydrogens again are off. If it were H6, it would be correct, but it's not. Let's look at choice C. We are given CH4 as our empirical formula. That is a 1 to 4 ratio. And our molecular formula, we are given C5H12. That is not a 1 to 4 ratio. If these carbons were a C3, that would be correct, but they're not. So finally, let's look at D, and hopefully this one is correct. CH2 is a 1 to 2 ratio of carbons to hydrogens. We are given C3H6, which, if we factor it down, is a 1 to 2 ratio. So that is our correct choice. Number 34. Number 34 is asking us if we have a compound that contains 40% calcium, 12% carbon, and 48% oxygen by mass, what is the empirical formula of this compound? We have calcium. Its molecular weight is 40.078 AMU, and it equals 40% of our compound. So it's very likely that we only have one calcium. Let's look at carbon. It has a molecular mass of 12.011 AMU, and it also is about 12% of the compound. So we're likely looking at only one carbon as well. Oxygen, however, has a molecular weight of about 16 AMU, and it accounts for 48% of the compound's total mass. So in order to figure out how many oxygens we have, we want to take 16 times the number of oxygens and have that equal 48. So when we do the algebra on that, we're taking 48 divided by 16, which is equal to 3. So we have 3 oxygens that make up our compound. So our empirical formula, our lowest common formula, is 1 calcium, 1 carbon, and 3 oxygens. Number 35. Number 35 is asking us to find the empirical formula of a compound that is 85.7% carbon and 14.3% hydrogen by mass. What we want to do is something very similar to what we did in the problem before, number 34. We want to take the percent of carbon in our compound, 85.7%, and divide it by carbon's total weight, which is 12.011. That should give us 7. And then we also want to do the same thing for hydrogen, which is take its total percentage in the compound, which is 14.3%, and divide it by hydrogen's molecular mass, which is 1.008, and that should give us 14. And then we reduce. 17 will go into 14 twice. So our reduced empirical formula is CH2. And this concludes our review.